Okay, quick overview of 1.4 and 1.5. Everything is slope. You have been dealing with slope since you were probably in a pre-algebra, definitely an Algebra 1 class, still even when in an Algebra 2, and even in geometry. So you've seen it pretty well for the last 3 or 4 years, pretty consistently, with everything that we've talked about. Or everything that we're going to kind of overview. Remember, slope is just the rate of change. It's the rise. It's the change in y over the change in x, which is just the rise over the run. If you have any sort of points or coordinates, you're just going to take your two values and subtract them. The y values get subtracted on the top. X values get subtracted on the bottom. It does not matter which point you choose as long as you stay consistent with the x and the y values. So if you pick the second point, so like down on number 1a where I have negative 3, 4 and negative 4, 2, if whatever I pick, whatever I want to be my y2, if I want to go negative 2 minus 4 over, and I want to subtract basically from here to here, then I have to do the same thing with my x value, and I have to go from the second point to the first point. So negative 4 minus a negative 3. Remember, everything's a negative or a subtraction. Change the signs, and then I would just have negative 6 over a negative 1, which is going to reduce to a positive 6. You don't have to write it as a fraction. If it's a whole number, you can leave it as just 6. But remember, that's going to be, in this case, up 6 over 1 to the right, and we go from there. So whenever we have point-slope form of an equation, basically you are going to be able to either find the slope or be given the slope and then one other point. Now, in some cases, like on 3, where you have 2 points, it's completely up to you as far as which point you choose as far as to be your 1 point. So like on 3, it says write an equation in point-slope form for the line passing through the points. So if it tells you to write it in point-slope form, leave it in point-slope form. You're so accustomed to putting it in slope-intercept form. Okay, slope-intercept form is just y equals mx plus b. If it tells you to put it in point-slope, then put it in point-slope and leave it like that. Okay. So like on 3, the first thing I need to do, or I would need to do, is I would need to find my slope of my line. So if I just go negative 6 minus a negative 1 all over negative 1 minus a negative 2. So negative 6 plus 1 is negative 5. Negative 1 plus 2 is just a positive 1. So my slope is, you can just write it again as negative 5. If we're going to put it in point-slope form, again, it's up to you. So you may have a different answer than somebody that's next to you. It doesn't matter, especially if you have 2 points. So since you have 2, you have 2 options. So if I go y minus y sub 1, it does not matter to me which one you make y sub 1. So if I go 1 minus a negative 1 and I pick the first one that I see, do that. My slope is negative 5 times x minus a negative 2. Now, to be perfectly honest with you, I don't know how the online assignment's going to have you do it, if it's okay with you leaving it like this or if it's going to want you. I would tell you to put it like this and leave it and change the 2 negatives to a positive, but I'm not sure exactly what the online assignment's going to have you do as far as how it's going to have you leave it. I would assume that it would have you leave it like this so you don't have all these negatives, but that's how I would tell you. At least simplify the 2 negatives into a positive, but don't go all the way and turn it into a slope intercept form. Leave it in point slope form. The next step to that last problem that we just had with point slope form would be to turn it into slope intercept form, like we've already talked about. This is the one you're accustomed to the most as far as y equals mx plus b. Remember, m is the slope, b is the y-intercept. Whenever we graph it, we go to the y-intercept first. We go up or down the y-axis, wherever that value is. If it's negative, we go down. If it's positive, we go up. And we plot our point on that number. So -3, -2, whatever it is, we go there. And then from there, we go as our slope goes. So if it's positive, we're going to go up. If it's negative, we go down. I always move to the right. Okay, and the only reason I don't move to the right is if I run out of room. Okay, if I graph, I usually like to put 2 or 3 points, at least 3. 2's okay, but 3's probably a little bit better, just to make sure that I'm going in the right direction and that my slope is the same. So anytime you have a line, so like on A, if it's f of x is equal to -3/2 x plus 2, I'm just going to go up to 2. I'm going to plot my point. So it's -3, so I'm going to go down 1, 2, 3, and then over 2. Do the same thing again. Now, if you have to, just keep going. It's really okay. Same thing as going down and to the right is the same thing as going up and to the left. So it's just the opposite movement. And then all I'm going to do is just run a straight edge through my line. Make sure you go the entire graph. That'll be important later when we get into some of the parallel and perpendicular stuff. Just run your straight edge. If you have an ID, a debit card, or a ruler, you need one. They're up on the shelf up there. Use that if you're going to do it by hand. Equation of a horizontal and a vertical line. What I always would use was, or what I used was Hoy and then Vux. Hoy is horizontal, 0 slope, and then y equals, and then with Vux is a vertical line, undefined slope, and then x equals. General form of an equation, I call it standard form, general form, whatever. It means the same thing. You're usually going to use this, and you're going to use it for intercepts, and you can turn it into y equals mx plus b. But whenever we go with standard form, the a, the b, and the c are all real numbers, and then they can't be, they're non-zeros. Okay, I always want to make my a value positive. Okay, everything else I'm not worried about, but I always want to make my a value positive. Okay, that's the only real stipulation that I have with standard form, is that it's positive and a whole number. Okay, I don't want it to be a fraction. I want it to be a positive integer, basically, and it'd be a whole number whenever I do that. Anytime we're doing intercepts, let y equal 0 for the x-intercept, and then do the same thing for the y-intercept. Let x equal 0 and solve for y, and then go from there. You're basically going to plot a point on the x-axis, you're going to plot one point on the y-axis, and you're going to use some sort of straight edge to draw your line. More on slope. Slope of parallel lines, they're the same. Okay, if they're two non-vertical lines are parallel, then they're going to have the same slope. They have two distinct non-vertical lines have the same slope, then they're parallel, and then same way, two distinct vertical lines, both with undefined slopes, are also parallel. So if you have two vertical lines, they're always going to be parallel. Same way with a horizontal line. If it's y equals and it's just a constant, they're going to be horizontal. Slope of a perpendicular line, remember this is a little bit different, that the products of the slope is -1. Really they're opposite reciprocals. Okay, so that means if they're going to be perpendicular, I'm going to flip my fraction or my whole number and then change it from a positive to a negative. So if I have perpendicular slopes, I better have one positive and one negative. I can't have two positives, I can't have two negatives, and then the fractions need to be reciprocals of one another. If you have a horizontal line and a vertical line, they are always perpendicular. Okay? A zero slope and an undefined slope are always going to be perpendicular to one another. Okay? That just should be fairly common sense. So it says the line graphs for the number of women and men living alone are shown in the figure below. Find the slope of the line segment. Describe what the slope represents. So basically it's going to be one of three things. They're either going to be parallel, they're going to be perpendicular, and they're going to be neither. Okay? There's really only three options. Which option can we automatically take off the table right here? Of parallel, perpendicular, and neither, which one can we take off the table? Which one is it not going to be? Can't be perpendicular. Why not? Because they're both positive slopes, right? And again, common sense is a good trait to have, and we can just tell that they're not perpendicular. So what I want to do, if I'm going to look at the slope of the women, okay, I'm going to pick the furthest right point, so I'm going to go 18.3 minus 14 over 2008 minus 1990 and go from there. So 4.3 over 18. Now I would just leave it this way and kind of go from there, then check the slope of my men. So 14.7 minus 9 over 2008 minus 1990. So since it's over the same span, then I should have the same value on the top and the bottom. Obviously it's over the same amount of years, so it's still going to be 18. And then 14.7 minus 9 is going to be 5.7. Yeah, they're not the same slope because it has 4.3 over 18 and 5.7 over 18, so they're not the same slope. So neither is going to happen. They're neither parallel nor are they obviously perpendicular. Last thing is average rate of change of a function. We kind of started talking about this with the difference quotient in 1.3. So how do we determine rate of a change for a graph that is not a straight line? Well, basically we're going to run a secant line. We're going to run a line through those 2 points and go from there. It's still slope. Okay? It doesn't change. It's just we have to figure out what our x and what our y value is. Okay? So we're going to be given our x value the majority of the time. We're just going to need to find the y value. Well, how do we find the y value? It's real simple. You're just going to take the x value that they give us. So if you look at like A, and it says x sub 1 is 0 and x sub 2 is 1, then all I'm going to do is just take the f of 0 and plug it in to my equation. So if I have x squared minus, I'm going to have 0 squared minus 3, so I have negative 3. I'm going to do the same thing again with x sub 2, or my second point where x is 1, and I'm going to go 1 squared minus 3, and I'm going to have negative 2. So all this is my y, and that's my y. Okay? My x values are what went inside the parenthesis. Again, it's still just a slope problem. It just looks fancier because we have x sub 1 and x sub 2. They give us what our first two x values are. We just have to solve the y value, is all we have to do. So in doing that, we're still going to run slope. So if this was x sub 1, I'm just going to call that y sub 1 and y sub 2. So negative 3 minus 0, or excuse me, negative 3 minus a negative 2 over 0 minus 1. And I'm going to have negative 3 plus 2 over a negative 1, which is just going to be a negative 1 over a negative 1. So my slope is 1. Only extra step that you had to do here was figure out where the y values fell on my function, okay, on my x squared minus 3. We would do the same thing if we went from 1 to 2, or if we went from negative 2 to 0. Okay, you just take whatever this value is that you have right here, and you plug it in there, and we do the same thing again to get our y values. Okay, x sub 1 and x sub 2 are just x values. You're just going to plug them into the function that they give you to find your actual y value on whatever function we're dealing with. Okay? Even though, like if you look up at the top where that blue, where that curve is, okay, even though it goes up to a certain point, we're just still looking for the average rate of change. So that's why we look at the beginning and the end. We don't care so much about what happens in the middle. We just want to know what happens at the beginning and the end. Okay? Things fluctuate through the middle, but it all kind of comes out in the wash because of where the beginning and the end is. Okay? We can kind of check to see where that average is.